Thank you. First, I would like to acknowledge some people that are working on this project with me. First of all, it's funded by the North Pacific LCC, my co-author Howard Schaller, and the group of people that we call the Pacific Lamprey Climate Change Vulnerability Steering Group, which is a multi-partner, multi-region group of people that we've been working with on this work. Kelly Coates from the Cow Creek Band of Umpquas, Damon Goodman from Fish and Wildlife Service, Mike Hayes from USGS, and Bob Rose from Yakima Nation. And also special thanks from our office, David Hines and Bill Brignon, who helped with the data, as well as the Climate Impacts Group, in which we got the downscaled climate data. So just a little bit of context for this project. We are involved with the Pacific Lamprey Conservation Initiative, which is something that has been going on since 2007. And that is a multi-partner collaborative effort with the goal of achieving long-term persistence of Pacific lamprey for really the purpose of supporting traditional tribal cultural use of Pacific lamprey. Pacific lamprey is a tribal trust species for the Fish and Wildlife Service and a very important animal to not just the Columbia River tribes, but tribes in California, coastal Washington, coastal Oregon, a very important animal for ceremonial purposes, medicinal purposes, cultural purposes. So this initiative, the Pacific lamprey are not listed, so this initiative is, like I said, has been going on since 2007, and it's a collaborative way to use limited funds and resources to try and sustain the species. So the three phases of this initiative: we did an assessment in 2011, we signed a conservation agreement in 2012, which is this picture here of these people, had a lot of signatories to the conservation agreement. And then the third aspect of this is the regional implementation planning process. So as part of the assessment, the results that we found, we looked at population demographic information as well as threat information for Pacific lamprey. And the conclusions that we found from the assessment were there's a high risk for interior Columbia and the southern range of Pacific lamprey. Low chance of rescue from healthy areas. If you look at this map, the red and dark orange areas are the more at-risk areas. The green would be more stable. So you don't see a lot of green areas throughout for healthy to rescue the more at-risk areas. The coastal areas are relatively lower risk. But one thing that came out of this assessment was that the identification of climate change as a key uncertainty for what was going to happen to Pacific lamprey in the future. So as part of the regional implementation planning process, we would like to include the impact of climate change on prioritizing restoration actions. That's the part of the conservation initiative that we're working on now, is trying to identify needed actions in all of the regional management units for Pacific lamprey. And this is something, if this is such a key critical uncertainty, we'd like to include, find out where they're most vulnerable so that we can include that information into the regional planning. So we did a pilot study on a climate change vulnerability index, and this was using the A1B and A2 climate scenarios, and it was using NatureServe climate change vulnerability index, and using the A1B and A2 climate scenarios, and also using the default air temperature and this moisture metric that they have in the NatureServe model. So, and these are just the general results that we found from that. You can see in mid-century for A1B, which is a more less pessimistic scenario, you can see that there are some presumed stable areas and then going to moderately vulnerable. But then at the end of century for A2, which is a more pessimistic view, you see that it changes to highly vulnerable and extremely vulnerable for the areas that Pacific lamprey would be in. But again, we wanted to, we thought it would be important to change the factors from air temperature and this moisture metric to something that was more specific to Pacific lamprey, which would be stream temperature and hydrologic factors. So in addition to that, in this North Pacific LCC study, or funded study, we changed from A1B to A2 to use the RCP 4.5 and 8.5, which is a more recent climate scenarios, climate futures rather. And then also we're using the most updated projection climate data, which is the CMIP5 data set. And also putting that hydrologic CMIP5 data through a VIC model, which is another way of getting it closer to hydrologic factors. It takes into account runoff, precipitation, land cover, and so running it through that model, again, makes it more specific to hydrologic factors, which would be important for Pacific Lamprey. So this is just a life cycle of Pacific Lamprey and showing, adding stream temperature versus air temperature and hydrologic timing. This shows where on the life cycle of Pacific Lamprey. On the right, you see, obviously stream temperature is going to be important for spawning, for egg hatching, for rearing. Pacific Lamprey rear in the sediment for up to 7 years. And then they transform and they out-migrate to the ocean. So obviously hydrologic timing is going to be important for that migration to the ocean and then return back to freshwater as adults. So both stream temperature and hydrologic timing we felt were important, again, to really get at the vulnerability of Pacific Lamprey to climate change. So in this particular study, these are the basins that we are analyzing, and we felt that this was a range of environmental and ecological conditions that Pacific Lamprey have experienced. We tried to spread these basins out, so these are the study areas that we're using for this analysis. Again, we're using RCP 4.5 and RCP 8.5. We're going to do 10 climate change models, and the first one that we're doing is that one on the bottom right. It's BCC-CSM1-1. They all have very long names, but that's the one that we're using first. So the NatureServe Vulnerability Index has 3 components to it. It has exposure to climate change, it has indirect exposure, and then it has species-specific sensitivity. And there are 3 sections that you have to fill out to use this approach. So the first one, exposure to climate change, is really how future projections are compared to what lamprey saw historically in these areas. So we used August mean stream temperature and hydrologic mean date. And so when we initially did this, we only had, we only have air temperature for CMIP5. And so what we did is we used scalars that Dan Isaac created to scale from air temperature to stream temperature. So we used August mean stream temperature and hydrologic mean date. And really what this is measuring is the change from historic exposure to future, both mid and end century exposure. And what we're doing, this, for example, this is in the Umpqua, and you make bins based on the historic August mean temperature and the historic hydrologic mean date. And what you do is you assign what's going to happen, the projected future years, into those bins. So for example, in the Umpqua, in the mid-century, you see that this is distribution of future years. So you're actually taking those projected future years and you're putting them into bins from insignificant to very high change. So in mid-century, you see there's more future years distributed in the insignificant change. And as you get to end century, there's more of these future projections into a high change. Change being change from historic to future. So that gives you an idea of how vulnerable they are to those future projections. The second index component is indirect exposure, and there's 4 questions you have to answer, and you answer those questions based on Pacific Lamprey from greatly increased to somewhat decreased. So how are they going to be affected by exposure to sea level rise? How are they going to be, what is their distribution relative to natural barriers, anthropogenic barriers? How are Pacific Lamprey dealing with predicted impact of land use changes from human response to climate change? So you have to answer those questions again. Is it in the greatly increase to somewhat decrease based on what you think Pacific Lamprey are going to be responding to these questions? And then sensitivities. How do Pacific Lamprey disperse? How do they move? What is the historical and physiological thermal niche, meaning what sort of variation in temperature have they seen historically? What sort of variation have they seen historically for hydrologic timing? What is the dependence on a disturbance regime in climate change? Do they depend on another species for habitat? Dietary versatility, interspecific interactions, and measured genetic variation. So all of these are getting at how adaptable Pacific Lamprey are to all these various questions. So that direct exposure, indirect exposure, and then these questions about species specific sensitivity goes into the NatureServe model, and what comes out is a calculated score for these areas on how vulnerable they are. So the results, this is just, like I said, we did 15 basins. This is a close-up of one basin. This is the Metau. And what you're seeing here is RCP 4.5 mid-century, RCP 4.5 end of century, RCP 8.5 mid-century, and 8.5 end. So we've got from mid-century of that kind of more optimistic view to the end of century of the more pessimistic view, the 8.5 climate future. And so you see for the Metau from these from this analysis that it is moderately vulnerable at 4.5 at the 4.5 mid-century, but then when you get to the 8.5 end of century, you're approaching extremely vulnerable for all of these aspects of Pacific Lamprey. And this shows, I didn't want to put all of them on here because it would be a lot to see, but this is a representative of the 15 basins that we did, showing, again, the 4.5 mid, 4.5 end, 8.5 mid-century, and 8.5 end, just so that you can see general trends of how these, how it goes from mid-century to end of century. But really, it's this is a better way to look at it. This is kind of bookending the 4.5 mid-century to the 8.5 end of century, and you can see Skagit moderately vulnerable into the highly vulnerable category, Chehalis from presumed stable into moderately vulnerable, Tualatin presumed stable into moderately vulnerable, Umatilla moderately vulnerable into highly vulnerable, Metau we just saw. Middle Fork salmon, highly vulnerable to extremely vulnerable, and so forth, South Fork eel. So all of them showed some change into the end of century to become more vulnerable. So the conclusions of this, we used a climate change vulnerability tool with stream-specific factors. All basins showed increased vulnerability from mid to end of century. The upper basin Columbia seemed to exhibit the most highest levels of vulnerability, and few basins were presumed stable at the end of century. So how are we using this information? I said at the beginning that we were going to try and use this vulnerability information in prioritizing restoration needs. So this is just an example of the Mid-Columbia Regional Implementation Plan. So the NS is Nature Serve Risk Rank. So on that first map that I showed you, it showed the risk of extirpation, relative risk of extirpation, and the Mid-Columbia had generally S1 to S2, which is critically imperiled or imperiled risk. So if you add on that the climate change vulnerability, which is moderately vulnerable to higher vulnerability at the end of century, what are some of the things that you should think about doing when you're prioritizing restoration actions? So in this area in particular, passage improvements for both tributary and main stem would be important so they can get to where, get to cooler water or get to where they're going. Side channel restoration would be very important. Again, they rear for a long time in sediment, so having those intact side channels would be important. Revegetation. In this area, there's a lot of canals for irrigation, so prevention of access into those canals would be something important in thinking about potential vulnerability to climate change. And then occupancy, spawning, and rearing surveys, just knowing where they are. The lamprey distribution and occupancy is we're getting better with this information, but it's still far behind what there is for salmonids. So just knowing where these animals are in relation to the areas that are going to be very vulnerable to climate change would be important. So the next steps for the study, completing simulations for the remaining 9 models. If you recall at the beginning, we've only done the 1 model, and now it's just a matter of, now that we have, know how to do it and everything, it's just a matter of running it for the subsequent 9 models. Incorporating results into the regional implementation plans for Pacific Lamprey for all the regional management units. We have 17 regional management units from Alaska to Southern California. And using information for prioritization of restoration needs in the vulnerable huck. So just like I showed you, going through an analysis of what the threats are there and really using this vulnerability information to prioritize with limited funds and limited people on what should be accomplished next. Thank you.
you've got climate change impacts, you've got other anthropogenic impacts. I'm wondering if in your analysis of climate change impacts, to what degree these other anthropogenic impacts affect your results, number one. Number two, in terms of prioritizing recovery actions, if you were to somehow fix all the problems, whether it's side channels or access or whatever it is, got rid of every dam, then I guess, can you prioritize your streams based on the absence of those other anthropogenic impacts, or are you going to? And ultimately, are there basins that you can't do anything about because of climate change? So are those, like lost? I'm sorry.
It's a lot of questions.
Jumbling around my head, are you capturing it?
I feel like it's like Miss America. It's like, which question do you answer first? So the first one about, so in the specific analysis, how much were anthropogenic things put into this analysis, or is it based on the whole prioritization of what we should do? Is that the first question that you had?
You've got your climate change impacts,
right,
and those results. To what degree are other anthropogenic impacts driving those results?
Yeah, that's a good question. They are, definitely. Because a lot of these systems are already heavily modified, which is, I think, where you're getting at. And so it was hard when we were trying to figure out the bins for historic thermal niche, and I talked about how much variation they'd seen previously. It's not like they're unmodified systems, and so just that was difficult to do going into like some of these areas like in the Umatilla or other places that already are so highly modified that it wasn't really accurate doing historic, just regular historic bins based on an unmodified system. So they're really, if that makes sense, it really is affecting it a lot. It's almost like magnifying, like we're starting from a different point that we are in some places that have a more unmodified system. So yeah, and so this kind of gets into your second question too. Like there are areas that are already so highly modified. We're already at the point where climate change is really affecting them because of the modifications and the anthropogenic, issues with those areas. So I think that I think there still are things that can be done in those, in those areas, and things that those people are really focusing on. But there are definitely, and some would say those are the areas that should be focused on because they're very far gone. But I see what you're saying as far as prioritizing other areas that you really can do something in areas that have more ability to rebound.
Christina, could you just talk a little bit about where projected ocean conditions fit into either what you've already been looking at in this overall analysis, or where that might be folded into next steps?
Yeah, so ocean conditions, not into this, there's sea level rise, which is something, but ocean conditions into lamprey restoration, that's something that is a topic that comes up a lot, and something that we don't know a lot about, how ocean conditions affect Pacific lamprey. We don't know how it affects, their prey, how they, because they're parasitic, how they attach onto hosts, what temperatures in the oceans. That's something that's always on the list, and it was in our assessment, it was on the list of critical uncertainties, but it's something that really we don't know a lot about how it affects Pacific lamprey. So it's definitely on the short list of things that need to be evaluated. We just haven't gotten very far.
All right. Thank you, Christine.
Thanks.